Hello, this is the notes for section 10.7. We're going to be discussing independent and dependent events. Basically, what this means is probability when more than one thing is happening at a time. Independent events don't depend on each other. They're independent. This would be like flipping a coin twice, rolling a die twice, drawing a card out of a deck of cards, replacing it, and then drawing another card. If you think about that, no matter what happens the first time, the second occurrence won't be affected. When that is the situation, to find the probability of both of them happening, you multiply them together. You just find each probability and multiply them together. So let's look at the example that's given here on the left. An experiment consists of rolling a number cube twice. What is the probability of rolling a 3 the first time and a 2 the second time? You have to stop and think to yourself, is the second roll dependent on what happened the first time? The answer to that should be no. Anytime you roll a die, it has a 1 in 6 chance of showing any of the 6 numbers. So the probability of rolling a 3 the first time would be 1 out of 6. The probability of rolling a 2 the second time would still be 1 out of 6, and then we would multiply these two fractions together. 1 times 1 and 6 times 6, we'd end up with 1/36. The second example talks about an experiment that consists of randomly selecting a marble from a bag, replacing it, and then selecting another marble. If the bag contains 2 red marbles, 1 white marble, and 7 yellow marbles, what is the probability of selecting a white marble and then a yellow marble? First, we need to know how many marbles are in there altogether. 2 plus 1 plus 7 is 10. So we want to know the probability of selecting white and then yellow. Sometimes it helps to set yourself up a little form here. And we know that we're going to, whatever we pull out the first time, we're going to replace it. So the probability of taking a white marble out of the bag first would be 1 out of 10. If we then replace that white marble, we still have 10 marbles in the bag, and 7 of them are still yellow. So we would have a 7/10 probability of pulling a marble out of the bag the second time. We'd multiply these together. 1 times 7 is 7, 10 times 10 is 100, and that's where we end up with the 7/100ths. Okay, so if we look at these examples here, let's just work through them one at a time. 6 cards are numbered 1 to 6 and placed in a box. 1 card is selected at random and replaced. Another card is selected at random. What is the probability of selecting a 1 and then a 6? The probability of selecting a 1 as the first card, there's only one 1 in the deck, and there are 6 cards altogether, so that's 1/6. If we're going to put that card back in, we still have 6 cards in the box. Only one of them is a 6, so the probability of drawing a 6 on the second draw is also 1/6. So we're going to just multiply those fractions together. 1/6 times 1/6 would be 1 times 1 is 1, 6 times 6 is 36, 1/36. A coin is tossed 3 times. What is the probability of the coin landing heads all 3 times? So let's kind of structure this a little bit. Here's the first flip, here's the second flip, here's the third flip. Every time you flip a coin, you have a 1 in 2 chance of it landing heads. Every time. It doesn't matter what happened the time before, you still have a 1 in 2 chance of flipping heads each time. So the first time 1 and 2, second 1/2, third 1/2. 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8. So we have a 1/8 probability of the coin landing heads all 3 times. Number 3, a bag contains 5 red marbles, 8 white marbles, and 7 green marbles. What is the probability of randomly selecting a white marble, replacing it, then randomly selecting another white marble? The key here is that we've replaced the first marble. We need to kind of structure our answer space a little bit. Okay, the probability of selecting a white marble, it looks like we have 8 And all together we have 5 plus 8 plus 7, which is 20. So that would be 8 out of 20. If we replace that white marble and we go to select another, we again have 20 and 8 of them are white. So it's just going to be the same fraction times itself. It would help to simplify it just a little bit before we multiply so that we can kind of do it in our heads. This top and bottom of each of these fractions is divisible by 4. That would give us 2/5 for each one. This would be 2/5 also. 2 times 2 is 4. 5 times 5 is 25. So the answer here is 4/25. Number 4, 10 cards are numbered from 1 to 10 and placed in a box. One card is selected at random and replaced. Another card is selected at random. What is the probability of selecting a multiple of 3, then a multiple of 2? Okay, we want to think to ourselves, how many of those 10 cards are multiples of 3? And that would be 3, 6, and 9. So that would be a 3 out of 10 chance. And then we need to know how many of them are multiples of 2. That'll be the even ones. 2, 4, 6, 8, 10. That's 5 of them. It's 5 out of 10. This fraction here should reduce to 1/2. This one will not. And 3 times 1 is 3. 10 times 2 is 20. So the answer here is 3/20. Okay, events are dependent if the occurrence of one event does affect the probability of the other. And then we're going to multiply the probabilities together, but the second one is going to be altered slightly. A class has 18 boys and 12 girls. 2 students are chosen at random. Now you're not going to want to select the same student twice. So you would have to figure out what happens to your total number and to your top number after you've selected the first student. So what is the probability that the students chosen will be a boy and a girl? From the way they've answered this here, we need to say and then a girl, that the first student chosen will be a boy and the second student chosen will be a girl. So I'll walk through this with you. 18 boys plus 12 girls is 30 students altogether. So the probability of a boy being selected first times the probability of a girl being selected second. There are 18 boys out of 30. And now we've selected a boy out of the group and he is no longer available for selection. So we now only have 29 students total. And so our bottom number becomes 29. There are still 12 girls though, so we'll leave that one at 12. Okay, from here we can sort of pre-reduce some of these fractions. These are both divisible by 6. This becomes 3. This becomes 5. And I think that is all we can do. 3 times 12 is 36. And 5 times 29 is 145. Now this could be your answer. It looks like what they have done is written it as a percent. So we would take 36 divided by 145. That gives us 0.248, which is about 24.8%. Okay, the probability of selecting 2 boys is a little different yet. This would be the same, this 18/30ths, we'll leave it as 3/5. We've already done it. That's the probability of selecting a boy first. Now that boy is no longer available for selection. He's already been picked, so we would leave him out of this next piece. Now there are only 29 students to choose from, and only 17 of them are boys, so that's where the 17/29 came from. And you can do the math here on the rest of that one if you'd like to verify their answer. So let's work through these examples that are at the bottom of this page. Number 5, a bag contains 3 red marbles, 5 green marbles, and 2 blue marbles. 3 plus 5 plus 2 means 10 marbles altogether. What is the probability of selecting a blue marble, setting it aside, then selecting a red marble? That's where the difference is from the work that we did on the page before this. This time we're setting it aside rather than replacing it into the bag. So the probability of drawing a blue marble first would be 2 out of 10, 2 blue marbles out of 10 marbles altogether. We'll go ahead and reduce that to 1/5. Now they want to know the probability of selecting a red marble after one of the blue marbles has been removed. There are still 3 red marbles, but now there are only 9 marbles total instead of the 10 we originally had because one of the blue ones is missing. This reduces to 1/3. So we'll, like we did before, we'll multiply those probabilities together. We have 1/5 times 1/3 gives us 1/15. Number 6, 26 cards with all the letters of the alphabet are placed in a box. What is the probability of selecting a vowel, A, E, I, O, U, setting it aside, then selecting another vowel? So we would start by saying there are 5 vowels out of 26 letters altogether. Once we've selected a vowel, if we don't replace it, there are now only 4 vowels remaining and only 25 letters altogether. We can pre-reduce this one just a little bit by saying 5 and 25 will reduce. This would be 1, this would be 5. 4 and 26 are also divisible by 2. So this becomes 2/65. That's our answer there. Number 7, a bag contains 8 orange marbles, 5 blue marbles, and 7 yellow marbles. That is 20 altogether. What is the probability of randomly selecting an orange marble, setting it aside, then randomly selecting another orange marble? So to begin with, we have 8 out of 20 for the first orange marble. For the second, there are now only 7 orange marbles and only 19 altogether. So we would go ahead and if we multiply that out like they did in the example above, we would take 8 times 7 is 56. 20 times 19 is 380. Oops, 380. And 56 divided by 380 gives us, looks like 14.7%. We take that as our answer. And number 8, 10 cards are numbered 1 to 10 and placed in a box. What is the probability of selecting one even card, setting it aside, then selecting one odd card? Well, we know to begin with, half of them are even. 2, 4, 6, 8, and 10 are the even ones, so that gives us a 1 in 2 chance. I'm kind of pre-reducing this. This started out life as 5/10. Now we have to think we're wanting to select an odd card for the second one. There are still 5 of them left, but now there are only 9 cards altogether in the box. So I just sort of pre-reduced everything. That would be 5/18. We could leave that as our answer. Now, if you have any questions remaining after going through these notes, I will be available in seminar tomorrow, and we can ask questions in class. The worksheet is due tomorrow at the beginning of class, and I'll be happy to go over it with you at that time. Thank you.